So in our lesson today, we're going to add and subtract rational expressions. But before we do that, let's look at what the basic rules for adding and subtracting ratios looks like. So our ratios are in the form of fractions. So if I ask you to take 1/3 plus 3/4, we know from our previous math that these are like adding unlike units because our denominators are not the same. So thirds and fourths are not equal to one another. So in order to add or subtract those, we have to find our lowest common denominator. So the smallest number that 3 and 4 will both divide into is 12. So what I'm going to do is make my denominators be 12. But in order to do that, I'm going to have to multiply my first times 4 over 4 and my second times 3 over 3. So what that gives me is 4/12 plus 9/12 is equal to 13/12. No addition and subtraction with rational expressions can ever be done unless the denominators are the same. So that is the same idea when we have rational expressions with variables and exponents and different expressions in our denominators. So let's first look at some monomials. So you see I have 15a squared bc cubed, 16b to the 5th c squared, and 20a cubed c to the 6th. Now what I want to find first is what's called our lowest common multiple. So that's going to be the number that all three of these will divide into. So if I start listing multiples of 15, 30, 45, 60, and I do the same for 16 and go 16, 32, 48, and so forth, and do the same for 20, 40, 60, 80. And I continue to do those multiples until I find the smallest one that's in common with all. I can find that my lowest common multiple of 15, 16, and 20 will be 240. Now that takes a little bit of work to find, but you're going to list those multiples until you find a common multiple. Now, as far as the variables are concerned, my variables, which I'm going to look at my a's first, remembering that they're going to have to be able to all become the same without division. So I can't get rid of a cubed because my second term does not have it. So as far as the variables are concerned, I'm always going to take the highest degree of each. So I look at a squared, no a's, and a cubed. My lowest common multiple will be a cubed. Now let's look at our b's. So I have a b to the 5th, and no b. So I'm going to take the highest degree, which would be b to the 5th. And then I look at my c's. I have c cubed, c squared, and c to the 6th power. So I will take that c to the 6th power, and my lowest common multiple is 240, a cubed, b to the 5th, and c to the 6th. That's the number that all of those numbers, all three, will divide into. It's the smallest number that all three will divide into. All right, now I'm going to ask you to try this one. So if you want to pause the video and then check back with the solution. So the solution is the lowest common multiple of 6, 9, and 4 will be 36. Then I look to my variables. The x's, the highest degree is x cubed, so that's the one that I'm going to take. Then I'm going to look at my z's. Again, the highest degree is z to the 2nd. And last, I'm going to look at my y's. And my highest degree is y cubed. So technically, I want to put that in alphabetical order here. And I'll end up with 36 x cubed, y cubed, z to the 2nd power. All right, now, what if our expressions have sums and differences in them? Well, the first thing I'm going to want to do is I want to get the most factored version of each expression. So I'm going to look at x cubed minus x squared minus 2x, and I'm going to factor that. So I'll look for my GCF first, which is an x, and then I'll look at this trinomial and see if it factors again. So I have x squared minus x minus 2. I'm going to say that that's going to factor into an x minus 2 and a x plus 1. And I'll do a quick outside-inside check. Outside gives me x, inside gives me negative 2x, which I know will combine to be negative 1x. All right, so let's go over here and now factor this expression. So I can see that that's a perfect square, and that is the doubles of the square. So this looks like it's a perfect square trinomial. All right, now, just as I did before, so technically this is really x minus 2 squared. So I'm looking at each term separately. Now, when I'm looking for common multiples, each term has to be present in the other expression. So this guy has an x. That means over here, he's going to need an x. So I'm going to give him an x. Over here, he has an x minus 2, but he has an x minus 2 squared. So I need to give him another one. Now, that's what I'm doing. I'm taking both expressions and I'm trying to get them to match. He has an x plus 1, which means that he needs an x plus 1. So I'm going to give him an x plus 1. So this time, our lowest common multiple would be they each now have an x. They each now have an x minus 2 squared, and they both have now an x plus 1. Now, they didn't originally, but that's how you find your common multiples. You look at what the other one has, and you're going to have to give it. So this one needed 2 x minus 2's, so I gave it, and I squared it on the left. This guy needed an x to match the left, and he also needed an x plus 1 term. So I need to make both sides match. All right, if you want to take a minute and try this one on your own and check back for the solutions. So again, I'm going to take the first expression and factor. So that leaves me with x squared plus 2x minus 3, which looks like it can be factored again into x plus 3 and x minus 1. I'm going to come over here and factor the x squared plus 6x plus 9. And again, this one looks to be a perfect square trinomial. So my outsides and insides give me 6x, and my lasts give me 9. All right, I can rewrite that as x plus 3 squared. Now, if I'm trying to make them match, and that's my ultimate goal, is to make sure both expressions have all of the exact same terms. That means that my right term is going to need an x to match. It's also going to need an x minus 1. My left term needs to match and have an x plus 3 squared. So my lowest common multiple is going to be the quantity of x times x plus 3 squared times x minus 1. That is what, those are the factors that make both expressions match. They both have the lowest common multiples in each. All right, so now we're going to put those ideas of finding lowest common multiples to work and add our algebraic expressions. So these rational expressions have unlike denominators at this point. So there's no addition that is allowed with unlike denominators. So the first thing I'm going to do, I'm going to change my wording. Instead of finding the least common multiple, I'm now finding the least common denominator, which is the same thing as the multiple, but now you're looking at the denominators. So I'm going to look at 6 and 14 first, and I'm going to try to find a number that 6 and 14 both divide into. So after a little bit of work, I find that they both divide into 42. All right, just as I did before, I'm looking for the highest expression of a's. So I'm going to need an a squared because my right term has that. And I'm also going to need a b squared. All right, so to make both denominators be 42a squared b squared, I'm going to have to manipulate this expression. So the first one, I'm going to have to multiply by a 7 to make the 6 be a 42. I'm also going to multiply by a squared and an extra b. So I have to do that on top and bottom. So I'm only multiplying by 1 here. All right, so that's going to give me 35 a to the 4th power b plus. Now I need to see what I need on the right-hand side. So what multiplied by 14 gives me 42? Well, that will be 3. And then I need no more a's. I have all the a's I need, and I have all the b's I need. So I just simply need to multiply the top and the bottom by just a 3. So you can see I'm only multiplying by 1. I'm not changing the value of this fraction. I'm just changing the appearance of it. So that gives me 27 over 42a squared b squared on the bottom. So this is what I have. I have 35 a to the 4th b plus 27. Now you might want to look to see if I can combine anything, which it doesn't look like I can. And you might want to see, can it be simplified? So do 35 and 27 have any common factors? Well, no, they don't. So this is going to be my solution. 35 a to the 4th b plus 27 divided by 42a squared b squared. All right, go ahead and pause the video and try this one, and then check back with me when you're done. All right, so I'm looking at 2 and 12. So 2 and 12 will both divide into 12. This side has an x and a y squared. So that's going to be my common denominator. Now I'm going to make them match. So I'm going to need to multiply the left by 6xy so that I have 12xy squared. But I have to also do that to the top. That will give me 18x cubed y on top. Plus, now I'm going to look at the right-hand side. So 12xy squared doesn't need anything, so I don't have to change this because this was already our common denominator. So I'm just going to go ahead and bring 5 with me. So now I have 18x cubed y plus 5. Now you might say, well, these have common factors, but if I factor just this term, then it's going to mess up my whole expression. Remember, I needed those common factors in order to be able to add those two expressions together. So that's going to be my sum when I'm done. Example, you can see that I have 2 different expressions. So this makes it a little bit more complicated. So what I'm going to do is I'm going to take each expression and I'm going to factor them out so that they're broken into factors instead of terms. So in the first one, I'm going to divide out a 3 and make this x minus 5. In the second one, I'm going to factor out a 6 and make that x minus 5. Well, if you look at both of those terms, they're almost identical. They both have an x minus 5. So the only thing I'm going to have to do is fix this 3. Now, I can't make the 6 be a 3, but I can make the 3 be a 6. So I know that my lowest common denominator is going to be 6 times x minus 5. Well, that means, so I'm going to cancel that I even have these anymore. I'm going to have to multiply this by 2, which means that I have to multiply the top by 2 as well. Now, when I multiply the top by 2, I have to multiply everything by 2. So that's going to give me a 2x plus 20. In my second term, I see that I already have my lowest common denominator. So I'm going to go ahead and just leave that alone. So this is what I have right now after finding lowest common denominators. I have 2x plus 20 over 6 times the quantity of x minus 5 and 3x plus 15 over the quantity of 6 times x minus 5. So I'm ready to go ahead and do my subtraction. Now this is what I want you to be careful. When you subtract this is a common mistake. We have to take that negative to both of those terms. Well, that's going to give me a negative 3x and a negative 15. So that I'm making my distribution of both terms. So now go ahead and collect those terms up there. So I have 2x minus 3x, which is negative x. I have 20 minus 15, which is positive 5. And in the denominator, I have 6 times the quantity of x minus 5. Well, these almost look similar, so I'm going to see if I can simplify that any more. So in the numerator, I'm going to pull out a negative 1, that little divide out a negative 1 trick. That will give me x minus 5, and in my denominator, I'll also have a factor of x minus 5. And once they are factors, you can go ahead and divide those out. X minus 5 divided by x minus 5 is just 1. And this rational expression will simplify to be simply negative 1/6. Okay, I'm going to ask you to try one similar to this. So if you want to pause the video and then check back to see how you did. So if you're back with me, I'm going to take the first one and factor out a 2. That's going to give me x minus 2. I'm going to take the second and factor out a 4, which also gives me an x minus 2. So my common denominators here, it looks like I'm going to need to multiply the top and bottom by 2 on this first rational expression. Now remember, take 2 times everything on top, which will give me 2x plus 10 over 4 times x minus 2 minus 3x plus 8 times 4, divided by 4 times x minus 2. Again, my denominators are the same, so I can go ahead and perform my subtraction. But when I subtract, I have to distribute that negative to both terms. So that will give me 2x plus 10 minus 3x minus 8. Okay, so you're going to see something similar here. We have negative x plus 2 over 4 times x minus 2. So it looks like, again, I'm going to be able to pull that negative 1 out, and I'll have an x minus 2 over 4 times x minus 2. And now that they're all factors, I can go ahead and cancel and be left with a negative 1/4. Okay, so you have to be real careful that you make sure you distribute that negative 8. All right, let's look at our last example today. So our last example involves complex fractions. So we know that complex fractions are just the division. Remember that this is just division of this expression divided by this expression. Now what I'm going to do, instead of adding the top together and subtracting the bottom together, which you could absolutely do, what I'm going to do is I'm going to first look for the common denominator of all my fractions. So I'm going to look around. So I have an A, I have a B, I have a B, and technically this guy's going to have a denominator of 1. So now I'm going to look and think, well, my common denominator is going to be pretty simple. It's just going to be an AB, because I'm going to multiply these together, and I'm going to give this guy an A, and I'm going to give this guy an AB. Now what I'll do is I'm going to multiply the top fraction by AB and the bottom fraction by AB. But when I do that, I have to distribute that AB to both terms. So it's like I'm multiplying by AB over 1, technically. All right, so now let's do my distribution. So I'm going to have AB over A plus AB over B divided by, then I'm going to distribute in the denominator, AB over B minus AB over 1. So now I can simplify anything that I can. A divided by A is 1. B divided by B is 1. B divided by B is 1. And AB divided by 1 is just AB. So let's see what I have left. I have a B plus A over 1s in my numerator. And I have an A minus AB in my denominator. So you can see that I was able to subtract my fractions and add my fractions and divide my fractions all in one step just by distributing the common denominator of all terms first. So I ended up getting one fraction that is no longer complex. And I combined my fractions in the process. I have B plus A over A minus AB. If you want to try one more of those, go ahead and pause this video and then check back with me. All right, if you're back with me, you'll see that my common denominator again, lowest common denominator is going to be AB. So I'm going to multiply once again everything by AB by distributing. So that's going to give me AB over A minus AB over B divided by AB over B plus AB over A. So I'll go ahead and cancel what I can, divide those A's out, divide those B's out. On top, I'm going to have a B minus A. In the denominator, I can cancel those B's and I can cancel those A's, and I can end up with A plus B. Now, if I do that little trick, that if I pull out a negative up here, it's just going to make my B be negative, so that's not going to be helpful in this problem. So that's going to be my solution, B minus A over A plus B. All right, I'm going to put some problems for you to try. If you have any questions, let me know. I hope you all have a wonderful day.